Hello, this is Mr. T and I'm going to guide you through the vocabulary words for Unit 3. Let's start with intermolecular forces. Intermolecular. Intermolecular forces are any forces of attraction or repulsion that exist between neighboring molecules in any given substance. Examples include dipole-dipole, dipole-ion, and London forces, all of which you will learn in class. In this image, for example, you see a schematic of the forces that act between two water molecules. Conductivity. Conductivity is the ability of any substance to conduct electricity through it. Salt in water and copper wires are examples of conductive substances or materials. And here you see schematics showing both of them. Bond length. The bond length is the distance between the nuclei of two bonded atoms in a molecule. It's usually measured in units of angstroms, abbreviated with an A. An example here is the length of the oxygen-hydrogen bond in the water molecule, which is approximately 0.95 angstroms, and you can see this shown in the picture below. Bond strength. The bond strength is the strength with which a chemical bond holds two atoms together. It's usually measured in units of energy, for example in kilojoules. And the stronger the bond is, the shorter the bond length will be. For example, here we see two molecules, one of hydrogen and another one of hydrogen chloride, and they have different bond strengths, and consequently we also have different bond lengths. Resonance structures. Resonance. Resonance structures are any of two or more possible Lewis structures for a given molecule. The important thing to remember is that resonance structures are different only in the position of the electrons around the atoms in the molecule. For example, here we see two resonance structures for the molecule of ozone, oxygen 3. As you can see below, the three oxygen atoms remain in the same place, and the only thing that changes between the two structures is the relative position of the electrons that are shared between the nuclei of the atoms. VSEPR model, also known as VSEPR model. This stands for the valence shell electron pair repulsion model, and this model is used to predict the shape of individual molecules. For example, in the image below, we see different geometric configurations for different molecules with different numbers of atoms. For example, a molecule with two electron domains surrounding the central atom, and you will learn more about this later in class, usually has a linear configuration. A molecule with three peripheral atoms surrounding the central atom has a trigonal planar structure. 4 atoms has a tetrahedral structure. 5 atoms has a trigonal bipyramidal structure, and 6 atoms has an octahedral structure. These different structures depends on how many atoms surround the central atom of the molecule. Lewis structures. Lewis structures are diagrams that show the bonds, represented by lines, and the free electron pairs, represented by dots, for all of the atoms that appear in a given molecule. Here in the image below you see different examples of Lewis structures for different compounds, and you will actually learn how to draw these structures in class. Hybridization. Hybridization is the process by which new or hybrid orbitals are formed by the combination of existing atomic orbitals. For example, in the image below, we see one s orbital combining with 3 p orbitals to form a new sp3 hybrid orbital. And again, you will learn more about this in class.